Good morning, ladies and gentlemen. Thank you for the opportunity. Gary, thanks for the invite. I've been asked to talk about systems thinking in mineral project evaluation. I'll probably link on to what's been spoken about in the past 2 days. So my agenda is I'm going to start with a basic question relating specific to mining. I'll talk about a few basic truths and current practices. Then I'll split the presentation into 2 parts. We will be doing the thought experiment, the paper that has been handed out. And we'll get to a point where we resolve this problem. Then Harry's going to be talking about how we make it happen. And then I'll come back and finish with part B, where I'll give a bird's eye view of the process. So I don't need to teach you or tell you what the value chain looks like for mining system. And you all know all about the technical stuff around it. I don't. I'm an industrial engineer by background. But it looks very much like a linear system. A lot of sequential dependencies. However, within each of those blocks, there are a lot of parallel streams going on. So it's a bit more complex than just this very simple value stream. The question I'm going to be talking about is where should improvement efforts be focused in this system so as to maximize value? Now, when we talk about improvement efforts, we can talk about day-to-day improvement efforts. That's typically in the operations management sphere. And we can also talk about projects, which is on the higher, on the strategic level, which aims to improve the total value chain. So let's start with a few basic truths and current practices. So what we experience today is more change. We experience more complexity, more competition, and even more chaos. So all in all, we need to deal with much more uncertainty in our environments. And I can guarantee you it's not going to become less complex. We're going to have more competition, more change. So the question is, how should we deal with all this change, complexity, competition in our organizations? Our good friend Albert Einstein had the following to say: if we want a better result, you'll have to do something different. Doing the same thing and then to expect a different result, that's insanity. So therefore, if we want different results from our organizations or our companies, we had better manage differently. So what are the current approach typically to managing organizations today? I found this quote by Pieter Pretorius, which states the following. He said, costs, the identification, measurement, and control are the most thoroughly worked, if not overworked, business area. The annual cost reduction drive is as predictable in most businesses as a head cold in spring. It is about as enjoyable. So you might think that this might be applicable to how we run companies today, because most companies have a great focus on cost reduction and cost management. So maybe just think about how long ago you think this quote was made, how long ago this was written. 10 years ago? 100? Well, Pieter Pretorius was probably close to just being born at the time, if it's 100 years ago. The right answer is 1964. So it's more than 50 years ago. Which means in my lifetime, it does not seem as we've changed our approach to management. There's still very much a focus on cost. And every year we still have our annual cost reduction drive, and we expect different results. I think we're bloody well insane. And also because we pay lots of money for our resources, we make them work as much as possible. In other words, sweat the assets. So how do we go about managing our operations? The first thing we see is that there's often a relentless focus on removing uncertainty or variability. And here are just some of the things that we do to try and get rid of Murphy. We implement quality programs, for example, TPM, ISO 9000, whatever other numbers we can think of, and Six Sigma. We do rigorous maintenance, total productive maintenance, reliability-centered maintenance. All of these are aimed at trying to reduce variability. We implement lean, good housekeeping, setup time reduction, top time. We try to optimize the supply chain, and typically supply chain optimization is focused on optimizing the cost. We also look for real-time accurate data. Real-time accurate data means Murphy is not present in our data, ERP systems, SCADA systems, and hopefully if we have real-time accurate data, we will be able to make better decisions about the future. We implement employee programs, training, gain sharing, trying them to get better results and provide better outputs. And then often we do projects to enhance efficiency and also then to reduce cost per unit, or typically in mining cost per ton. So how much management time is typically focused on the above? And also how much time is spent on fighting fires? And I think you will agree with me that quite a lot of management time is consumed by fighting fires and then trying to reduce Murphy or uncertainty. So what's the result? So it's the same quote. I just add the last part, which is printed in bold. It's about costs, the annual cost reduction drive. But 6 months later, costs are back where they were, and business braces itself for the next cost reduction drive. So we seem to be caught up in an endless loop. What's going to happen if we are really successful with all of these efforts of ours? Removing uncertainty, we're going to end up with perfect market information. We'll know exactly what the demand is, which we don't know today. We will also know about the price sensitivity, how prices will change over time. And also customers won't change their minds. Isn't this the perfect world we're looking for? We will have no breakdowns. Process times will be constant. In reality, we know process times are represented by distribution, and it's not a normal distribution. Our processes will be perfectly under control, and capacity can be balanced. Employees will be on time. Wouldn't that be marvelous? They won't make mistakes. They will neither strike nor demand a raise. Suppliers will always deliver on time, the right quantity, the right quality, and they will not surprise us with a price increase. This is what's going to happen if we achieve everything that we are doing typically on a day-to-day basis. So if we end up with such a perfect environment, what do you think? It's going to be difficult or easy to manage your operations and implement projects? So you decide for yourself. So what we're going to be doing next is we're going to be conducting a thought experiment. And we know a thought experiment is an experiment we don't physically do, but we just talk through it, and having sufficient background and intuition, we'll know whether this experiment will work or not. And obviously there are advantages to doing a thought experiment as opposed to the real thing. The first advantage is it doesn't cost you any money. In reality, it might cost you money. It doesn't take you a lot of time. In reality, it might take you a lot of time. And finally, if you use animals in your thought experiment, you don't have to apply for ethical clearance. So what we have is the utopian organization, where all the things that I've just described in the previous slide, the perfect environment exists in this environment. And it's a very simple environment. We only have 2 products. We've got 4 resources, A, B, C, and D. We've got 8 processes. Each resource is doing 2 processes. There are no setup times. The process times are constant. The suppliers are always on time. Right quality, right quantity. And we know exactly what the flow looks like. So if we look at the left-hand side, we can see what is necessary to make product X. So if we follow the arrows in the opposite direction, and on the right-hand side, we see what is necessary to make product Y. And we see that the center section are common processes that are required for both products. So if you want to make one of X, you've got to go through process B1 and C2 once. If you want to make one of Y, you've got to go through processes B1 and C2 a second time. The other reality that describes this environment is that because we're talking about a single resource for two processes, so if we look, for example, at processes, if we look at resource D doing two processes, it cannot happen at the same time because it's a single resource doing it, and so it's applicable to all of them. They cannot substitute for one another. Each resource available 2,400 minutes per week. And our fixed cost is a total of 6,000 Rand, which is 1,500 times 4. The demand is fixed and constant, 60 units of X per week at 95 Rand per unit, which we can assume to be the optimum price. Any price increase will drop the demand. Any price decrease, the demand will stay the same. 60 units of Y at 105 Rands per unit. So the first question is, which one of the two products do you think is the most profitable product? So what we see is that Y sells for a higher selling price than X. If we look at the data within the little case, you see that the total processing time for X is more than the total processing time for Y. And if we look at the raw material cost, the variable cost, 40 Rand for Y, that's 45 Rand for X. Okay, so we come to a conclusion. Do you need a lot of time to make this calculation? Okay, so that's the first question. And I'm not going to ask you what your answers are. I'll show you some of the historical data of answers, and you'll decide whether your answer is in line with the historical data. The second question is, if we start looking at improving this system, which one of the two proposals should be implemented, we also have the choice to do both. We can decide to do nothing. First proposal proposes that we decrease the processing time on process B1 from 15 to 14 minutes. On C2, we increase it from 5 to 8 minutes. So that center section, the overall time will increase from 20 to 22 minutes. And the cost to implement this project is going to be a once-off 5,000 Rand. And I'm using low numbers, simple numbers, so that the math does not stand in the way of the understanding. Everything else will remain the same. The second proposal on the table proposes that we decrease the time on process A1 from 20 to 5, on process C1 from 20 to 15, and on process A2 from 10 to 5. And the cost of this proposal is a once-off 3,000 Rand. Okay, so now I've given you very little time to think about it, but you've seen this before. And I've also seen that it really doesn't matter how much time you give people to answer this, the results are basically the same. So these are the decisions we need to make. Which product's the most profitable, X or Y? Maybe they're equally profitable, maybe none of the two is profitable. And which proposal? 1, 2, both, or do nothing? Okay, so hopefully you've made up your mind. So let me give you some results from some of the student groups that I've taught. And I've got data much further back than 2015. And these are from 3 different entities. The one is GIBS, the business school. So many of the MBA results are from GIBS. Some of the MBA results are from the NMMU business school down in Port Elizabeth. And what is indicated there as MEM is from the engineering faculty at UP. There's one of them. So you'll see the number of students that have participated in this, the product decision. For example, the 2015 MBA Green Group, only 9.5% got the correct answer, the correct proposal 12%, but nobody got both right. And the important thing is, if you want to understand systems thinking or demonstrate your understanding of the systems thinking, then you've got to have both right. And we see that the highest number there for getting both right is 5.5%. So that's not a good hit rate. And the question is, why don't we get the right answer, even in the absence of Murphy? So here's the logic. It seems to be a fact that Murphy is considered our number one enemy in our businesses. Why do I say or make that claim? It's because we spend so much time on trying to deal with Murphy. All the things that we do to try and prevent Murphy from happening in the future or be able to deal with him in the future, and also the firefighting. So that seems to be true. In the case of my students, in your case now as well, I require them to make decisions in the absence of Murphy. So your first observation might have been, or thought might have been, that if I require you to make decisions in the absence of Murphy, it's going to be easy. And if it's easy to make decisions in the absence of Murphy, the expected outcome is that most students arrive at the same correct answers. And if that happens, then what should I teach them? Is how to get rid of Murphy. It's what I call the classical approach to management. And it's also known as the detailed approach to management. However, the reality is, the numbers prove it, that making decisions in the absence of Murphy is found to be difficult. And this is the proof: most students arrive at the same incorrect answers. So what we see is that those two things are in conflict. It cannot happen. It's not possible that most students get the same correct answers, while at the same time, the same students get the same incorrect answers. So one of the two doesn't exist in reality, and we now know which one it is. We also know those two things are in conflict, difficult or easy. We know it's difficult. And if both of these are required to lead to making decisions in the absence of Murphy to be easy, now this is just the reality that exists in reality. So this must be wrong. And I say it's a wrong assumption. Murphy is not our biggest enemy. Therefore, this is not what I typically teach my students. It's typically what we need to teach engineers, not managers. So getting rid of Murphy is really an engineering problem rather than a management problem. Even though as managers, we must enable engineers to do that. So there's some unknown problem or root cause that exists that makes it difficult. So in order to solve this problem, students should be taught how to solve the unknown problem. And the future reality is, when I test in the exams and assignments, is most students arrive at the same correct answers. So what is the problem? And I can speak a lot of time on this. I'm just going to go through it very quickly. We make a lot of assumptions, and our assumptions come from our experience. And we've got to be very careful of people that have gray hair, that includes me, claiming that experience is the reason why we should be doing something in the way that we are doing it. We also make assumptions based on what we've been taught. Obviously, universities are places of integrity, so they will not teach you the wrong stuff. Well, unfortunately, they do. We also like majority thinking. We do a lot of benchmarking. We see what other people are doing and just assuming that if somebody else is doing it and they're seemingly successful, that must be correct. And then we fall into a lot of habits, which means we don't think about why we're doing things anymore. We also forget what the goal of the company is, and we have the wrong measurements for proper decision making. We typically see in mission statements of companies that our goal is to be the lowest cost provider of whatever, ... And that's not the goal. If you want to really be cost effective, shut down the company, cost is zero. You cannot be more cost effective than that. The goal is to make more money and it should not be confused with the means. It's two different things. The goal is making money. The means is on this type of mining or this type of manufacturing or this type of service. And the means can change. Kodak is a very good example. Kodak was very good at chemical film processing. But a new technology came along and they didn't adapt, and Kodak is in trouble today. And the ironic thing is that Kodak invented what is killing them today, and that's digital photography. So they stuck to the means, and that prevented them from achieving their goal. Mention has been made of the accountants. Accountants should never be allowed to be part of decision making. It's management's responsibility. Accounting is about recording the past. It's about accuracy, and it's about recording the past. Whereas decision making is about the future. When we look at the data, it's about the relevancy of data and getting an answer which is good enough. And then the accountants tell us, but an IRR of 7.14656% is the threshold. So how did they arrive at that number? It's a meaningless number. We also lack clarity of meaning. If I was to ask each and everyone to write down a definition for something like productivity, I'll probably get as many answers as we have people in this room. We measure parts of the organization in isolation. We measure marketing on their own, maintenance on their own. Marketing, we want to maximize sales. Operations, we want to reduce cost per unit, volume and total cost. And these two measurements are in conflict with one another. That's why so often we've got the fights between marketing and operations. We focus on solutions rather than problems. We don't typically understand what our real problems are. And it's not very cool to talk about problems because you're negative. And many of us being engineers, it's so easy to revert to solutions because now I can demonstrate my technical expertise with this complex solution that I can design for you. And to make it worse, Murphy's reality. All the variability and uncertainty that exists in our systems. So I think these are all related in some way. There's some common cause. Can explain all of them, which then lead to our organizations often not achieving their goal. Now, my hypothesis is we do not understand systems. So the moment you start on applying systems thinking, it becomes much easier to solve problems. So let's quickly talk about systems. Similar to the natural sciences, and really systems are part of the natural sciences, systems are governed by natural laws. These laws must be understood and applied in day-to-day, as well as strategic management decisions. These laws cannot be broken. You can only break yourself against the law. There's the law of gravity. You can ignore the law of gravity, it's not going to ignore you. And it's because the law is unbroken that you hurt yourself. So the system laws allow us to understand the dynamic complexity of how all the parts work together. In other words, it's about the relationships between the parts. Whereas the detail complexity, which is typically what we keep ourselves busy with, is about understanding the parts. And unfortunately, this is our primary focus. So let's talk about a few system principles and how we ignore them or apply them non-systemically. The first important thing is systems are goal-seeking. And we must remember what it is. And we must understand and not make the assumption that cost effectiveness and profit effectiveness are two different sides of the same coin. It's two different coins. You either can be profit effective. Sometimes you've got to be very cost ineffective to be profit effective. And being cost effective does not necessarily lead to profit effectiveness. We've also talked about the wrong measurements, cost per unit, cost per ton, and I know I'm stepping on very thin ice. Cost per unit, cost per ton does not exist. It's an imaginary figure, and we cannot use it for decision making. And I know it's one of those holy grail measurements in mining. Utilization as well. Sweating the assets is a very bad practice. All the components in your system must support the goal directly or indirectly. It's there for a reason. But we do not understand necessity and sufficiency. Necessity means each of the components are necessary. Sufficiency, all of the components together will allow achievement of the goal. One of them missing, the goal cannot be achieved. And that's why I absolutely hate it when we talk about primary and secondary functions. They are only functions, and they are all necessary, and together it becomes sufficient. We also often assume that necessity means utilization. Just because I have it, it must be working all the time. I'm not paying you to do nothing. Sometimes doing nothing is a very good idea. I mean, my car is standing idle. It's my most expensive resource, and it's doing nothing. If I am sweating that asset, my cost is going to go up. So I'm not going to do it. Measurements influence behavior. If we have the wrong measurements, it's going to drive the wrong behavior because people respond to measurements, and we're going to have the wrong outcomes. The system is also more than the sum of its parts. There is an emergent property, a characteristic that exists on system level that is not the property of any of the components. And this comes from the relationships between the parts. A company can only make money when all the parts work together. And we revert to things like profit and cost centers and start managing each of the parts as if it's a separate little company, and we expect something like maintenance to at least break even. So they must generate some income, but it's funny money. It's moving money from one pocket to another. Systems are non-linear. Cost thinking is a linear thinking. If we reduce cost by a certain amount anywhere in the company, the total cost of the company goes down by that amount, but no more. In systems thinking, a small increase in cost might increase your profit significantly. And it's not linear, and we need to understand that dimension. All systems are constrained. You've got a constraint whether you like it or not. It's either in the market or it's in your company. Either have sufficient capacity, which means you need more market demand, more market capacity, or you need more internal capacity. We think constraints are just a goal-rat fad. It's a POC fad. It's not. It's there whether you like it or not. You can ignore your constraint will not ignore you. And the important thing is if you want leverage, you've got to find your constraint and deal with it. Subsystems or components are optimized, and you see I write it in italics and inverted commas, because optimization is not possible in a dynamic system. Because of all the variability, you will never know when you are at the optimum point. The moment Murphy strikes, your optimum point moves, and it moves all the time. Even though we can improve systems, it can never be optimized. We also don't understand that the capacity of the system equals the capacity of the constraint. The analogy of a chain is as strong as the weakest link. Anything that's stronger is not improving the strength of the chain. So to improve the constraint is to improve the system. To improve a non-constraint is an illusion. We also experience counterintuitive behavior, which means the opposite happens to what we expect in the system. And those signals must tell us that we've got the wrong understanding of the system. I can give you many examples. Probably the new mining charter is going to have a few counterintuitive outcomes, but let's not talk about that one. Also, systems are part of bigger systems. When our systems perform badly, we often blame the external environment, when in reality it's the bad decisions that we've made internally. So don't confuse bad management and bad luck. So let's get back to this problem. So the first question, which of the two products is the most profitable? And what I'm going to do is I'm going to do a parallel analysis of the detailed thinking, which is probably what many people follow, and the systems thinking. So the first step always is you've got to find your constraint. If you don't know where your constraint is and you make a decision, it's like playing Russian roulette with one chamber empty. You've got a very good chance of killing yourself and ending up in a bloody mess. So we've got to know what the goal is. And obviously the goal, you cannot have a constraint unless you have a goal. So a constraint is something that prevents you from achieving your goal. So the first thing we do is to calculate on the load on the 4 resources. And we see that resource B does not have sufficient capacity. The available capacity is 2,400 minutes a week. So therefore, it's the constraint. It has a workload more than its available capacity. So the second thing is, now that we've got an internal constraint, we've got to prioritize. If you have a market constraint, you don't need to prioritize. So this is typically how we will calculate profitability. We will do some cost allocation. We listen to the accountants. That's one of their methods, which we have now transferred to future decision making. And we look at the selling price of the two products, the variable cost, the contribution margins, the capacity required for each of the products. We calculate some cost per minute or cost per hour, in this case, cost per minute. We allocate the cost using something like activity-based costing. We find out what the unit cost is, and we see that product Y is about 10 times as profitable as product X. Your answer? I'll ask you. So now the decision is to maximize product Y, since according to this calculation, it is the most profitable. If you use the dynamic focus, you'll understand that fixed cost is fixed cost is fixed cost. Allocating it's not going to change it. But we nevertheless do. We have to allocate fixed cost, even nobody can explain to you why. So irrespective of the decision we make, going for X first, Y first, equal quantities, the fixed cost is going to remain the same. So the way to do it is to look at the contribution margin. So what do you want? The constraint determines how many units you're going to be making. So what do you want? 50 Rand every 15 minutes or 65 Rand every 30 minutes? It's a problem we give our kids, and they know the answer. We can obviously see that 50 Rand every 15 minutes is much better than 65 Rand every 30 minutes. So we calculate the throughput rate, which is the contribution margin divided by the constraint time. The interesting thing is, I can take you back to a quote. The earliest quote I could find was 1981, where this is already in the management accountant's textbooks, contribution margin divided by constraint time. So if we follow the dynamic approach, we're going to decide to maximize X. Now we've got to calculate the mix because we're limited by the capacity of B. So if we maximize the quantity of Y to be 60, the available capacity left for X is going to be 40. If we use the dynamic focus, which requires to do 60 of X, we can now make 50 of Y. Step number 4, calculate the profit. And that's the really simple form of profit. It's all the revenue, volume times selling price, minus all the variable cost of what you've sold, minus the total fixed cost. And nothing is left out. So if we look at the detail focus, we're going to maximize Y, calculate X to be 40, and then we're going to make a loss of 100 Rand per week. If we use the dynamic focus, we maximize X, quantity of Y is 50, X has the highest throughput rate, and we're going to make 250 Rand profit per week. And what do we have? It's the same system. Nothing has changed. We only made our decisions differently. And you might argue, but in this case, we've got a total volume of 100, 60 plus 40, in this case, 110. So it's the volume that drives profitability. Now in this case, the higher volume does make the bigger profit. But I can show you some examples where you can make more profit with lesser volume, and it's still because of the throughput rate. So what about the two proposals? So proposal 1, increase in overall production time. Proposal 2, very much an improvement of efficiency. So there's our basic formulas against which we're going to judge these proposals. Now, if I look at proposal 2, I don't even have to make calculations. All I have to ask is what's going to happen to each of these components when I implement this proposal. So the first thing that's going to happen, my fixed cost is going to go up by 3,000 Rand. It's a cost. It's a once-off cost, but it's going to go up. Variable cost stays the same. The selling price stays the same if I do proposal 2, and the volume sold will stay the same because the volume is determined by the constraint, not by A and C, which we change. So if the fixed cost goes up, the rest stays the same, profit is going to go down, And if profit is down, investment stays the same, ROI is down, obviously cash flow is going to be down as well. This is the most popular answer, go for proposal 2. Why? Because I reduce the time, the cost per unit is going to go down significantly. And that's going to be considered a saving. But where's the saving? If fixed cost hasn't gone down, and your fixed cost has gone up, and your variable cost has stayed the same. Can you see that it's an illusion? So there's a wrong assumption. Time is money. Time is only money on a constraint. On a non-constraint, it's just there, but it costs you the same whether the resource is working or not. When reducing the process time on ANC, you are more efficient, but you're not more effective, not making more money. The fixed cost remains, all the goal measurements are down, profit down, ROI down, cash flow down, and those are the relationships. So is it a good idea to spend time and resources on a project that has no positive outcome? Increasing the efficiency is not the objective. And with traditional methods, proposal 2 will be accepted. That saving will be divided into the cost of the project, and I'll calculate the payback period. So even though the cost per unit can be demonstrated to go down and there's a positive payback period, it's not real money, it's an illusion. What about proposal 1? No, you can't increase the time, it's less efficient. Yes, it is less efficient, but let's make a few calculations. The cost per unit is up because now the time it takes for each of products X and Y is going to go to 77 minutes and 52 minutes, but B gains 110 minutes because there's a reduction of 1 minute per unit on B1. And 110 units are going through B1, so therefore the gain is 110 minutes per week, which means we're going to make 3 more units of Y. Even though Y is the less profitable product, we've already made the quota for X, so there are 3 more that can be made. There's the possibility for 10 more. We've got to calculate the load on C because there's no change in the load on C because the time is increased. It's still within its available capacity. And I calculate the profit, and suddenly I see there's a 78% profit, increase in profit, which doesn't seem to make, and you see it's a counterintuitive outcome because the cost per unit has gone up. Payback period, and this is a real payback, it's about 26 weeks. The increase in profit, 195 Rand, divided into the 5,000 cost increase. It's more effective, even though it's less efficient, using the dynamic complexity. And even if we have to take a loan to fund this project, it's got to really be a very, very, very expensive loan before it's not going to be worthwhile. I'll make a few comments on some of the discussion when I get to my conclusion. What I would like to do now, and I've just got a few slides left, is just to show you what I think is the generic systems thinking process. And even though it was defined by Goldratt, I don't claim it to be a TOC thing, theory of constraints, because theory of constraints is founded in systems thinking. You can go back and see long before Goldratt started writing and teaching TOC, all the principles that he is teaching, or he was teaching, are founded in systems thinking. So he defined 5 focusing steps based on the analogy of improving the strength of a chain. Step number 1 for a chain is identify the weakest link. Step 2, make it stronger. Step 3, go back to step 1. There will be a next weakest link. If there wasn't the weakest link, then you will find a chain with infinite strength. The same for companies. All companies are constrained. If a company is not constrained, you will find a company that makes infinite profits, and I'm yet to see that company. I would love to invest in that, but the share price will be infinity as well. However, he converted the 3 steps for a chain into 5 steps. So the first one is the same, identify the constraint, and the basic premise is if you want to improve your system, you've got to improve the constraint. However, he didn't go to step 2 in the chain analogy to improve the strength of the chain. He says, let's rather look at the existing capacity availability of the constraint and maximize what we currently have. So he calls it, decide how to exploit the system's constraint. And exploit is a really harsh word. It means to take advantage of. It's exactly the meaning. And it means to take advantage of the scarce capacity of the constraint. A minute lost on the constraint is a minute lost for the system. A minute lost on a non-constraint is nothing. It's just there. Okay, so that's the second step. Nobody's got a problem with this. We intuitively understand that we've got constraints. We've got to make sure that the constraint is as busy as possible. Remember, the market can be the constraint as well. So then the focus should be on marketing and not internal capacity to cut costs. The third step deals with the non-constraints, which says subordinate everything else to the constraint. So that very simply means that non-constraints should only work that amount of time to keep the constraint busy and no more. Because the moment they start doing more, you're not making more money. You cannot sell more. It's the constraint determines the volume sold. And if non-constraints do more, they start impeding the flow. Now, the question is, what about the cost that is associated with non-constraints? Yes, it does cost you money. And what we typically try to do so often in companies, we try to balance the capacity, get rid of all the excess capacity or seemingly excess capacity we have on non-constraints. The moment you do that, and I'll give you a link to a separate narrative slideshow, or narrated slideshow, which deals with why we should not balance capacity. The moment you balance capacity, it means you turn all your resources in a constraint, which means that's when you start fighting fires, and the next fire is totally unpredictable, because the moment the Murphy strikes anywhere, the biggest occurrence of Murphy is your constraint. And that's why we're chasing backwards and forwards, trying to deal with all these fires. And the more variability you have, the more unbalanced your capacity must be. And if you've got enough unbalanced capacity, sufficient capacity, now it's not excess capacity, it's protective capacity. It's capacity that protects you against the variability. The only real thing that you need to worry about is the variability on your constraint. And that's the one you're going to be focused on. That's where you focus your lean and your TQM and your Six Sigma and setup time reduction. And then you're going to improve your capacity of your constraint. By doing that, you're going to improve the flow, you're going to improve the volume sold. And the argument was made, but there's such a lot of variability in mining. Therefore, it's much more important to have even more unbalanced capacity. And as you start managing your constraint, the exploiting of a constraint will help you to see where the variability exists in non-constraints, which might affect the flow through the constraint. And that's when you're going to start focusing your efforts on improving non-constraints, which have the biggest effect on the flow through the constraint. So up till now, we haven't spent money. And this is what we've done in our case, our thought experiment. We've identified the constraint to be B. We exploited the constraint by making sure the constraint works 2,400 minutes. And we prioritized on X based on the throughput rate. And we've increased the profit from -100 to +250. On the argument that beer companies are different to mining, the principles are still the same. What do you want in a beer company? You want flow. What do you want in the mining industry? You want flow. So in the end, it's all about flow and what determines your flow and what can prevent your flow. So when I look at Mali, the gravity is 9.8 meters per second square. When I come to South Africa, it's still 9.8 meters per second square. So the laws don't change because of the different industries. The application might differ slightly, but the laws are still the same. So we can learn from other industries. Okay, the fourth step is elevate the system's constraint. This is the equivalent of step number 2 in the chain analogy, is add capacity to your constraint, elevate, bring the capacity to a high level. Just going back to step number 3, subordinate. That's the one that drives the cost accountants crazy. Because now I've got resources sitting idle from time to time. And because they've got this idle time, they'll be able to handle uncertainty without impeding flow. And then they ask the question is, what do I do with all this idle capacity? Where do I allocate the costs? Why do you want to allocate the costs? I'm not going to change it. So don't let the accountants, I'm not saying we should fire the accountants, but let the accountants do what they're supposed to do. That's record the past. Leave the decision-making to management. We should not satisfy the accountants. It's not about satisfying. You see, the accounting statements are very illogically set up. And if you start looking at the rules of GARP, the more you try to make your accounts look good, most probably it's going to get worse for your company in reality. Because one of the best ways, now thinking about a manufacturing company, even for a mining company, if you want to increase your profit, produce a lot of stuff which you don't sell. Your profit on your income statement is going to go up because all the cost, fixed and variable cost associated with inventory you've produced but not sold, that cost is taken out of the income statement and put on the balance sheet as an asset. And that increases the profit, but it doesn't increase your real money that you earn. So we satisfy the accountants, but we're not making real money. And we create the illusion of profitability. Step number 4, elevate the constraint, is when we implement proposal number 1. Making the change on process B1 and C2, and suddenly the profit goes up significantly. The difference between exploiting and elevating, exploiting, the effects are immediate, doesn't cost you money. Elevate costs you money, that's typically a project, and it takes time before the effect is seen. In this case, we've had a payback period of 26 weeks. Step number 5 says, if the constraint has been broken, go back to step 1, but do not allow inertia to cause a system constraint. And that just makes sure that we embark on a process of ongoing improvement. When you read the literature on the 5 focusing steps, you'll typically get the explanation that I've just given you. However, I've been teaching this for the past 25 years, and many people from your companies have seen this before. And then they get back into your company, and then they say, but we should be doing this differently, especially young engineers. Now, what do you think is going to happen if a young engineer walks into your company and says, cost per ton is a really bad idea? He's typically going to be instructed to the following and say, by the time you become the CEO, you can change it. But at this point in time, this is the way we do it. We're not going to change. The best way to bring about the change, and it's been mentioned, is to do it top down. The challenge for CEOs and executives today is not to have a technical expertise. We don't want marketing people to be CEOs. We don't want engineers to be CEOs. We don't want finance people to be CEOs. We want people that can see the big picture and be able to integrate and look at the business as a whole and not get stuck into the day-to-day management as they often do. The 5 focus steps, if you just look at the 5 focus steps, it seems very sequential. But the moment you start implementing this in a practical way, we see that it's not as sequential as the 5 steps suggest. So what I've done, and this I've included in my lectures as early as probably the year 2000. And I've published an article on this, I'll give you the reference, where I say, but there's a bit more to the 5 focusing steps. And all I've done is to take the 5 focusing steps, and I'm not claiming any big contribution, but just to make it a little bit more practical. So it starts out by, and I know it's very small, but if you get the hard copy or can get an electronic copy as well, you'll be able to see this. It starts with defining the system goal. You've got to have the goal in mind whenever you define constraints. Without the goal, constraint definition is not possible, and you've got to define the measurements. Because the measurements tell us where we are, and when we make decisions, predict as to where we will end up. Without that, we cannot make decisions. So there we have step 1, identify the system's constraint. All these decision steps are the parts that I've included now. First question, is the constraint physical? Now, we do get constraints other than capacity constraints and market constraints. These are things like policy constraints and behavioral constraints. A policy constraint might be something we make the decision which product to go for based on cost per unit. That had us end up at a profit of minus 100. And if we have a policy constraint or a behavioral constraint, you cannot exploit and subordinate to it, because exploit means make the best possible use of scarce capacity. Now, if it's a wrong policy, I've introduced a first alternative step number 4, which states design the new policy or change the behavior. Now, just on changing behavior, you're not going to change behavior if you change the structure, because people respond to measurements. How they are measured will determine how they will behave. If you want to bring about change, change the measurements. And then you're going to see change, not the structure. So we've got to design a new policy. So the policy to prioritize is going to be based on throughput per contribution margin per constraint minute. We go back to step 4, remove the old rules, make sure that you do that. Because if you leave them in place, the old rules will always win because of habit. You've got to make sure that the old rules are removed. You go to step 1, identify the constraint. In our example, it was Ben. So there's step 2, exploit the constraint. You work 2,400 minutes, first on X, then on Y. Subordinate to the constraint A, C, and D. Only work that amount of time to keep the constraint busy. Then I check, is subordination possible? You see, the system is robust. If you pick the wrong constraint, subordination will not be possible because you cannot subordinate a real constraint to what you think is a constraint when it's not. I've very rarely seen this, that we pick the wrong constraint. Most of the time we pick the correct constraint. If a subordination is not possible, go back to step 1, you are going to find the correct one. Is the constraint broken or about to be broken? You must always be forward-looking. Exploiting well adds capacity, often. Then I ask the question, it's not broken, or answer the question, not broken or about to be broken. Is the system performance satisfactory? Yes. And I'm going to go through this loop continuously. And this is your typical day-to-day operations. And what are you going to do in your day-to-day operations? You're going to improve your constraint, the short-term improvements, exploiting, and you're going to subordinate. And if you see that non-constraints are impeding flow on the constraint, you might be improving them, but only those. If you're not happy with your performance, then we go to step 4, elevate the constraint, add capacity, it's physical capacity. And this is a project that we are doing. You see it's a different type of loop. And you check, is the constraint broken or about to be broken? Not broken. In our case, we did not break the constraint. Am I happy with the performance? Now I'm doing 445 and not 250 anymore. And you continue doing your day-to-day operations. If the answer to this question is yes, the constraint is broken or about to be broken, remember, if you've got a capacity constraint, you're going to break it. And you want to keep it in the same place. Adding capacity is something that takes time. Why? There are laws of physics. You cannot create something in 0 time. Building a power station takes 10 years. You're not going to build it in a year. Forget it. It's not possible. Now, the best example to explain how this part of the logic works, what we've seen in electricity supply is that the constraint was broken or about to be broken. In fact, Eskom went to government in 1997 and said to them, we're going to break this constraint in 2005. The market constraint is going to move internally. We're not going to have enough capacity. And we'd really like to keep the constraint in the market. As consumers of electricity, we want the constraint in the market, meaning enough capacity. As the supplier, Eskom wants the constraint in the market because the moment it's internal, all the pressure's on them to supply. So in their case, they say, is the constraint broken or about to be broken? Yes. 10 years from now, we're going to break the constraint. So we've got to start building capacity now if we want to keep it in the market. And then, is it desirable for the constraint to move? No. We want to keep the constraint in the market for electricity supply. Then you go to the second alternative, step 4, which I've introduced. Now you're going to elevate non-constraints, which are now the constraint, and you don't want it to be the constraint, or will become the constraint in the future. And can you see we've got a second strategic loop? So this is our first loop for projects. That's our second loop for projects. If you say it's desirable for the constraint to move, go back to step 5. But once you have the constraint in the place where you want it, you want to keep it there. And then you're going to run through this loop on a day-to-day basis, a strategic loop through this one as you expand your capacity. And when you see you're going to break the constraint, you don't want it to move, you're going to go through that loop. And then the rules remain the same, and you start getting a stability because the rules are not changing ever. If it is allowed for the constraint to move, that's also a strategic decision. So typically these will be projects, but all 3 of them will be strategic decisions. And I think that gives a an executive a very good framework for decision making as to where to focus. Obviously, the day-to-day improvement is going to be focused here, primarily on the constraint. Your projects should be focused on the constraint as well. So let's come to some conclusions. The moment we understand system principles, it allows us to stick to the real goal. But you've got to remember what the goal is. It allows us to revisit the measurements. What are the measurements that really link up to the goal? In fact, I challenge my students. If they can prove that this thing cost per unit, which includes a fixed cost allocation, has a correlation to profit of the company, I'll make sure they get a PhD for it, and they can choose the university to award it. And the two hypotheses you've got to prove is that whenever cost per unit goes down, profit goes up. Whenever cost per unit goes up, profit goes down. The examples I've given you already disputes both of those hypotheses. So it's not possible. So we're utilizing a measurement which has no real value and no real relationship to the goal. It also allows us to surface and challenge assumptions. And we do that by asking the question, why are we doing this? Unfortunately, the moment somebody asks why, and we cannot answer the question, because I say so, because we've done it like this for the past 40 years. It's habit, and we continue doing the things we are doing. It also allows us to manage the leverage points by identifying, exploiting, subordinating, and elevating to the constraint. It also allows for proper calculation instead of just speculation. Cost per unit down, profit up, that's a speculation. The important thing, however, is that we must make sure that the logic is sound. The answer lies in the logic, not in the number. So if I've made the calculation for the thought experiment, the numbers are exact. And the reason for that is there's no uncertainty. In real life, there's a lot of uncertainty. So give me an answer which is good enough. And don't tell me that the IRR threshold is 7.5.246%. It's a rubbish number. It allows us to see the wood from the trees and being able to explain effect, cause, and effect. And mention has been made that we are so often focused on short-term results. And cost-cutting shows immediate short-term results, but it doesn't show the effect that it has somewhere in the future because there's suddenly a lack of flow. We must be able to explain how our decision will lead to the outcomes that we predict are going to happen. So there's a list of some of the further reading that you can investigate for systems thinking. I've written a few articles in systems thinking myself. There at the bottom is a link to a narrated slideshow on why balancing capacity is a bad idea. So that's my story. Let's start with the questions.